In this section, we are going to learn about a theorem which is related to the midpoint of sides of a triangle. Perform a simple activity. Draw a triangle ABC and mark the midpoints of two sides of the triangle AB and AC. Mark it as E and F. Join the points E and F. Now measure EF and BC. Measure angle AEF and angle ABC. You will find that angle AEF is equal to angle ABC. So, EF is parallel to BC. Also, EF is equal to half of BC. Repeat this activity with some more triangles. So, you arrive at the so-called midpoint theorem. The midpoint theorem states that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is equal to the half of it. That is, EF is parallel to BC and EF is equal to half of BC. Now, my question is, why is midpoint theorem included under quadrilaterals? Even though the midpoint theorem is for triangles, it is proved using properties of a parallelogram, which is a quadrilateral. We will see this in action when we discuss the proof of the theorem in detail. Now come to the proof of midpoint theorem. Theorem statement: the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is equal to half of it. Given ABC is a triangle where E and F are midpoints of AB and AC respectively. Construction: through C, draw a line segment parallel to AB and extend EF to meet this line at D. And we need to prove EF is parallel to BC and EF is equal to half of BC. Proof: since AB is parallel to CD by construction, now with transversal ED, angle AEF is equal to angle CDF. What is the reason behind? Alternate angles. Mark it as equation number 1. Now, in triangle AEF and triangle CDF, angle AEF is equal to angle CDF from equation number 1. Now again, angle AFE is equal to angle CFD. What is the reason? Vertically opposite angles. AF is equal to CF. F is the midpoint of AC. So, the triangle AEF is congruent to triangle CDF by ASA rule, that is angle side angle. So, EA equal to DC by CPCT, but we know EA equal to EB since E is the midpoint of AB. Hence, EB is equal to DC. Now, in EBCD, EB is parallel to DC and EB equal to DC. Thus, we got one pair of opposite side is equal and parallel. Hence, we can say EBCD is a parallelogram. Since opposite sides of a parallelogram are parallel and equal, we can write ED equal to BC and ED parallel to BC. Or we can say half of ED is equal to half of BC and EF is parallel to BC. Or half of ED is nothing but EF. So, EF is equal to half of BC and EF is parallel to BC. Hence, the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is equal to half of it. Hence, proved. Now, come to the converse of midpoint theorem. What does the theorem states? The theorem states that the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. That is, AF is equal to FC. Let's see the converse proof. Given ABC is a triangle where E is the midpoint of AB and F is some point on AC. Also, EF is parallel to BC. So, construction we need to do: through C, draw CM parallel to AB. Now, extend EF and let it cut CM at D. We need to prove F is the midpoint of AC, that is AF is equal to FC. Let's see the proof. In quadrilateral EBCD, ED is parallel to BC as EF is parallel to BC is given a data. Now, EB is parallel to CD by construction. Since both pairs of opposite sides are parallel, we can say that EBCD is a parallelogram. Now, since the opposite sides of a parallelogram are equal, we can write EB equal to DC, but we know EB equal to EA. Why? Because E is the midpoint of AB. Hence, EA equal to DC. Mark it as equation number 1. Also, EB is parallel to DC as AB parallel to DC by construction. Now, with transversal ED, we can write angle AEF is equal to angle CDF. They are the alternate angles, which is the equation number 2. Now, take the triangle AEF and the triangle CDF. Angle AEF is equal to angle CDF from 2. Now, angle AFE is equal to angle CFD. They are the vertically opposite angles. Also, EA equal to DC from equation number 1. So, the triangle AEF is congruent to triangle CDF by ASA rule, that is angle side angle. Also, AF is equal to CF by CPCT. Hence, F is the midpoint of AC. Hence, proved. So, in this section, we have learned about the midpoint theorem and its converse along with their proof. Let's have a recap. Midpoint theorem states that the line segment joining the midpoint of two sides of a triangle is parallel to the third side and is equal to half of it. Now, the converse of midpoint theorem we have seen. The line segment drawn through the midpoint of one side of a triangle is parallel to another side which bisects the third side.